This call is now being recorded.
Dear participants, warm greetings from Rajiv Institute of Technology, Hassan. Good afternoon to you all. Hope you're all doing well. Today we have stepped into the second day of virtual FDP on data science and networking. Today's session will be engaged by our resource person, Dr. Balaji Prabhu. Currently, he is working as Associate Professor in the Department of Information Science and Engineering in Malnad College of Engineering, Hassan. Dr. Balaji Prabhu has obtained his postdoctorate from Indian Institute of Science, Bangalore in Computational Intelligence Lab, Department of Aerospace Engineering. His testimonials include Excellence in Research Award, Best Young Researcher in Data Analytics, Best Paper Award in Springer International Conference held at Kolkata, and he is the runner-up of Make in India Entrepreneurship Boot Camp during 2017. One patent has been filed under his name for populated place monitoring and medical alerts using wireless network analysis and response using cloud computing. His research work has been published in Scopus indexed 15 journals and SCI indexed 4 journals, and also 7 book chapters are after his name. He has conducted 45 hours of hands-on training as a resource person on artificial intelligence, machine learning, data science, and big data analytics for students and faculty members in various engineering colleges. Sir, we are very much honored to be associated with you. Such a distinguished personality you are. Thank you for accepting our invitation to become our resource person. Sir, it's over to you now.
Thank you, madam. Thank you for the introduction. Am I audible, madam?
Yes, sir.
I hope the screen is visible.
Sir, the PPT is visible.
Yeah.
You can continue, sir.
Good afternoon, Ananda. Today, so we shall discuss about the crux of machine learning. The title of the session follows the crux of machine learning. So these are some acknowledgements. So most of the materials of this presentation are based on introduction to machine learning course by IBM from Coursera, and from other web sources like CodeBats and WP Schools and others. Just copied content from other web sources. And also I referred the book Machine Learning by Tom Mitchell and Introduction to Machine Learning by A.M. Das. And the errors, if any, are due to me, and I really apologize for that. And the outcome of this session. So in today's session, so we'll be discussing about some applications of artificial intelligence and machine learning, and let's understand some basic terminologies like AI, ML, deep learning, data science, and also the difference between them. And we'll understand different machine learning algorithms like supervised machine learning algorithms, unsupervised, and reinforcement machine learning algorithms. So before we start with some theory or concepts of machine learning, let me drag you to the world of machine learning. So just by playing some videos. This is a robot which is developed to solve the Rubik cube puzzle, which is named as the Dectile. So the other application is and this is a robot which was developed to pluck the fruits, ripened fruits. You can observe it will pluck only the ripened fruits, maybe in a tomato or maybe in strawberries, and also it can work in both day and night as well. This is another wonderful application. Yeah, this is another wonderful application which was developed by Amazon. It was named as Amazon Go. So by using the applications Amazon Go, you no need to stand in a line on no queues, no lines. So when you visit any shopping malls, whatever the things, whatever the items you wanted to purchase, just put it into the cart. Just walk out through the gates. So once you walk out to the gate, so whatever the items you have added to your cart, it will automatically charge through your mobile application. And this is one of the wonderful applications of AI. Yeah. So in today's world, we keep hearing about a lot of terminologies, right? Such as machine learning, artificial intelligence, robotics, blockchain, big data, virtual reality, augmented reality, data science, data analytics. There are plenty of the terminologies and technologies there in today's world. Every day, day-to-day life, we just keep hearing about lot of terminologies. So let's not worry about all the terminologies. We just we stick ourselves to the theme of today's session, that is machine learning. So just learn about some basic terminologies with respect to machine learning. So all these ideas, maybe the machine learning or deep learning or any other, maybe the learning methodologies or learning technologies, all comes under a broad term or broad area called artificial intelligence. So artificial intelligence, maybe we have two terms, artificial and intelligence. The meaning of intelligence or intelligence, right? We, the human beings, are intelligent. So one who can behave rationally as per the situations. That can be considered as intelligence. So what do you mean by artificial intelligence? So when we can create the intelligence artificially, where we can create the intelligence artificially, obviously with the machines. When we create the intelligence artificially to the machines, that is called as artificial intelligence. It's an umbrella discipline that covers everything related to making machines intelligence. Next comes the machine learning. So as I told, whenever we try to create an intelligence to the machine artificially, and that is called as artificial intelligence. And machine learning is one way to achieve artificial intelligence, where we try to make machines to learn from data, learn from experience themselves. That is also one of the things where we are making the machines intelligence. That's a type of a subset of artificial intelligence. So where what to do? We'll make a machine to learn learn the data, learn from the data, learn from past experience without being explicitly programmed. This is very important. I just put it in double quotes here. The term without being explicitly programmed. So in conventional methodologies and maybe in the older days, we used to write a code to do any to solve any task, maybe for addition, subtraction, multiplication, anything. We used to write a code, maybe C program or Java program, anything. So where we are writing the code, we are giving the instruction explicitly to perform maybe the addition, subtraction, multiplication, or any other task, right? We are writing the code to do the task. But in machine learning, we don't give any instructions. Rather, we give a data. From the data, the machine will try to learn the things. So for example, let's say when I give an Excel sheet which contains some numbers, maybe some the two numbers, number A and number B, and next we have another column which says the symbols, maybe the addition, subtraction, multiplication symbol. So when I have A is equal to 2 and B as 3 and symbol as plus, 3 plus 2, obviously the output will be 5. By just looking into the symbol, the machine will try to learn whether this operation is addition, subtraction, multiplication, whatever. This is what we call as machine learning. Machine will learn to do that, to solve the task or solve the problem without being explicitly programmed. That is called as machine learning and deep learning. Deep learning is also like a subset of artificial intelligence, but deep learning is a subset of machine learning, where using deep learning we also make a machine to learn without being explicitly programmed. But in deep learning, we use a special type of technique to achieve a machine learning, which is called as a neural network. Next, so all the data science, right? So data science is not restricted to or not that belongs to any particular field or any particular domain. It's just a combination of it combines the multiple things. It includes statistics, science, mathematics, artificial intelligence, machine learning, deep learning, everything. So whatever we try to do with the data to extract some meaningful meaningful value from out of it, That can be called as, that can be considered as a data science or data science operation. For example, let's say whenever we're collecting the data, or maybe whenever visualizing the data, whenever we're applying some analytics on data, whenever we're applying some statistics on data, whenever we're applying some machine learning models on data, all the things whatever do with the data can be considered as data science. Computer vision NLP. Okay, let's not worry about this. And this is the diagrammatic representation which will distinguish between artificial intelligence, AI, machine learning, and deep learning. Observe here, AI is a broader term, the vague, the discipline, which covers all the methodologies or technologies or algorithms or whatever tool which will make or which will create intelligence artificial, which will make the machines intelligence. So one such a technology is machine learning. So again, you can observe here, deep learning is a subset of machine learning. So not only these two are a type of artificial intelligence, we have, as I told, natural language processing, computer vision, so plenty of ways are there to achieve the artificial intelligence. Then most of us will be, even myself and most of us having this two. What's the main difference between machine learning and deep learning? Both are learning only. Both we have some algorithms. And is it the only difference to say like the deep learning can be implemented using neural network and machine learning cannot be implemented by neural networks? No. You can also implement the machine learning algorithms using neural networks. But what's the main difference? Just observe, just staring at this slide, you can easily make out the difference between machine learning and deep learning. The major difference is here, the feature extraction. In machine learning, we have a person or we have a someone or somebody who need to extract the feature before feeding it to a machine learning model. So let's not worry about this classification phase here. Let us consider this as a machine learning model. The entire classification, this as machine learning model. Okay. So we have an input. So before giving the input to the machine learning model, we need somebody to extract features. For example, let's say, so I'm just feeding this input, which is a car. To learn this image as a car, we need somebody to teach us. The car something looks like this. It has got some 4 wheels. It has got this color or this shape. And these are some of the features. Maybe the color, or texture, or size, or maybe the weight, or maybe the height, or the number of tires, whatever. So we need somebody to extract features to to better understand, to learn the things by a machine learning algorithms. Once it learns the algorithms, definitely it will produce the output. So this is a machine learning. But when it comes to deep learning, again I'm giving the same input, okay, but maybe with a different color. Let's not, don't get worried with this. So I'm just giving the same input. So as a car, as an input. So here you don't have another extra person or maybe somebody to need to extract features. The deep learning models, the deep learning algorithms have the ability to extract these features by themselves. That is the main advantage of deep learning. But still, we have so many advantages, the difference between machine learning and deep learning, but this is the main difference between machine learning and deep learning. For example, let's say, so this is one of the advantages of deep learning models. For example, let's say, here I'm just giving the input as this car as an input to the machine learning model to learn. So what type of car it is, whether it is a car or whether it is a car or a bus or something, what else? Okay. So not to extract a feature as a human being, how many features I can extract? Maybe number of tires, or shape of a car, or size of a car, weight of a car, texture, color, maybe from 5 features or 10 features. Okay, as a human being, maybe we can extract maybe from 10 or 15 features. But when it comes to deep learning algorithms or deep learning models, deep learning models can extract n number of features, maybe from 50 features, 100 features, more number of features. That is the main advantage of deep learning model. So when you compare the accuracy of machine learning model with deep learning model, definitely deep learning model stands high compared to machine learning models. The major the point is while extracting the feature. So deep learning model can extract plenty, n number of features, which will make to learn the input data in a better way compared to machine learning algorithm. That's the main difference between machine learning and deep learning model. Next, machine learning. So what is the machine learning? How do machine learns? So we need to feed any textbooks, like maybe the PDFs or maybe the Excels or Word files to the machines and maybe the computers to read the data, to learn about any things, to learn about any problem, learn about any task. So that's what the machine will learn. The machine learning concepts was mainly derived from the human learning idea. As I told, the machine learning was mainly derived based on the concepts, based on how the human learns. Then, how does the human learns? The human learning is mainly can be categorized or can be considered in three different ways. One is learning under some expert guidance or learning under some teachers. Somebody who is expert in a subject directly teaches us. Here we have an expert who is we have somebody who is teacher who is already expert in the domain who is teaching us. So we are learning some game here to a teacher. This is when we are learning the human beings. Next, so based on the past experience, based on the data we learn from maybe the expert, we'll try to learn new things. We'll try to we'll try to learn the new things. That's the second way of learning the human beings. Next one is learning by ourselves, right? So we know that, right? So maybe if you consider the example of Arjun and Ekalavya. So Ekalavya learned the thing by himself, right? So Arjuna has got a teacher to train him. He has learned under expert guidance, but Ekalavya has learned by himself. So that is self-learning. So these are the main three categories of human learning that are heavy. As per the literature, so the human learning can be categorized into three categories or three types. Learning under expert guidance, learning from past experience, learning by himself. The same way, based on these concepts, or based on these, the methodology, the machine learning is categorized, or machine learning is can be categorized into mainly three or maybe the four categories: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So mainly, if you want to correlate this with the human learning, so it can be we can have supervised, unsupervised, and reinforcement learning. Supervised means working under supervision. So we have somebody to teach us. We have somebody while they are learning. We have somebody maybe the teacher expert. That is called as supervised learning. Non-supervised learning, we don't have anything. Like maybe from past experience or maybe from other relevant by maybe looking to somebody else, or maybe from other available features, and that to learn the things. That is unsupervised learning. And semi-supervised. Semi-supervised is a combination of supervised and unsupervised. Or maybe we can discuss about the semi-supervised maybe in further slides. Reinforced learning is same as self-learning. In reinforcement learning, we don't have any teacher or expert or maybe from past their experience. Rather, in reinforcement learning, we try to learn ourselves. That's the main place. Reinforcement. So based on some feedback, or based on some experience, based on some feedback, based on past whatever the drawbacks or whatever the way we went wrong in the previous the task, the previous steps, we try to improve ourselves step by step. That is called as reinforcement learning. So if we let's discuss each and every type of machine learning algorithms in detail. The first one is supervised machine learning algorithm. Supervised machine learning algorithm is nothing but whenever we are machine learns through a supervised data. So what do you mean by supervised data? With respect to human learning, the first category is learning under expert guidance. Here, so do we have anybody expert here to teach the machine? No, we don't have anybody, any external person to teach machines to learn from data. Rather, in a given data itself, we have something to supervise the data, which is in the form of label or labeled data set. Whenever you are given with the data which has been labeled, that's why I highlighted it. Supervised learning is when the model is getting trained on labeled data set. That is called as supervised machine learning algorithm. A labeled data set is one which has both input and output parameters. You can observe it. I have a data here where TID, refunds, marital status, taxable income, and chip. So based on this refund, marital status, and taxable income, so maybe from government or maybe from agencies has categorized these observations into whether this person has cheated or not. Yes, right? So we have input variables which are refund, marital status, and taxable income. This is our output variable, cheated, whether it is cheated or not. Right? This is our output, target, labeled, predictive variable. So when we have such a data set, we have an input and also we have an output values. And this is nothing but supervised data or labeled data set. Whenever you are given it or whenever you have a data such that, so you have both input and output labels and output columns, and obviously we can go for supervised machine learning algorithms. One such an example is how do we train our kids using a flashcards, right? Like A for apple, or maybe B for ball, or C for cat, something like that. We have an image and also we have a label for that, right? So we have an image, or input image or some data, and label for the corresponding data. And that is nothing but supervised data. So whenever we have a data which is which is being labeled, so we have to go with supervised machine learning algorithm. You can see here. So here I have input data which is apple, and also annotation labels in the form of these are apples. We describe them as these input images as described. So we have a labels attached to it. So using this, when I train a model, that is nothing but supervised machine learning model. Once I train a model, so I'll give a new data. Once I give a new data, my model should be able to identify this as accurate, whether it's an apple or any other corresponding. So this is what supervised machine learning algorithms. In supervised machine learning algorithms, mainly we have two categories or two type of algorithms, such as classification algorithms and regression algorithms. So why I'm giving this information here, because whenever you want to apply any machine learning algorithms, so you have to decide. First, you have to decide which algorithm I should apply. Whether I should apply supervised machine learning algorithm, or I should apply unsupervised machine learning algorithm. If it is supervised machine learning algorithm, you have to decide whether I have to apply classification algorithm or regression algorithm. If it is unsupervised machine learning algorithm, you have to apply some class A of unsupervised or class B of unsupervised machine learning algorithms. You have to decide. How do you decide? Based on the available data, based on the given data. So, how do you decide based on the given data? If the given data is labeled, then obviously your choice would be supervised machine learning algorithms. This is the data set given, so which has been labeled. Labeled means which data you should look into? The output column. So if we have an output column which has been given with the labels or labeled, then obviously your choice would be supervised machine learning algorithm. Okay, by just looking into data, you just decide whether yes, as this is labeled data, or to go with supervised machine learning algorithm. In supervised machine learning algorithm, whether you have to apply classification or regression, how do you decide? Based on the type of this outcome variable, output variable. So as I told, in supervised machine learning algorithm, we have mainly classification and regression categories. The classification, so as the name implies, so classification is, so whenever we try to classify the data into some categories and classes, some categories or some classes, maybe class A, class B, boys or girls, or maybe the professors, associate professors, assistant professors, maybe some different zone, Bengal zone, Mysore zone, different groups or different classes. Whenever we have a data output column, output variable, which has been labeled with discrete labels of different classes, then you have to choose a classification algorithm. It's a supervised learning algorithm where output is having a defined label which are discrete values. If you have a discrete values are not continuous. Discrete such as from class A, class B, class C, blood group, A, B, A positive, B positive, something. So the main goal here is to take the discrete values belonging to a particular class and evaluate on the basis of accuracy. And based on the number of classes available, we can categorize the classification algorithms into either binary classes or a multi-class classification algorithm. Binary class classification algorithm or multi-class classification algorithm. So what do you mean by binary class? Obviously it is so simple, right? When you have a two class, either 0 or 1, not only 0 or 1, two classes, either 0 or 1, or A or B, yes or no. something like that. Then you have two classes or two labels. So that type of algorithm is called as binary classification or binary class classification algorithm. If you have more than one classes, then that is called as multi-class classification problem or multi-class classification algorithm. One example is a Gmail. So you know that all of us use a Gmail. Right? When we log into a Gmail account, the Gmail server will be categorized into maybe the inbox, maybe the social media, then updates, promotions, something like that. Right? So whenever you receive an email, based on the content present in the mail, it will categorize into either inbox, as or spam, or maybe the social media, or social maybe the updates or forums or promotions or something. Right? We have more than many classes here. This is the example of multi-class classification. Next, regression. As I told in class supervised, the classification and regression. So when we have a class output variable which are doing discrete labels, then you have to go with classification. If the output variable is continuous. What I mean by continuous, some values are recorded through some intervals, some continuous values. Then you have to use, or then you have to go with the regression algorithm. So regression is a supervised task where the output is having continuous value. Here the main goal is to take the values much closer to actual output values. So the smaller the error between the created value and output value, the greater the accuracy of the regression model. So here I'll give two examples or two data sets to make you distinguish between classification and regression. See, I have given you this first data set. So by just looking into the data set, so the main goal is to predict, to say whether this observation or this person with these details has purchased something, some product or not. Right? Here I'm just trying to predict whether he has purchased or not. So either he has purchased is marked as not purchased is marked with C. Right? So here are the input data and output data. Right? I have given with output data as well. Where the output data are labeled. These are not continuous values, rather they are discrete values. So which has got two classes, only 0 and 1. So obviously your choice must be classification. First see, so by just looking into this data, you should see our input variable and output variable. Obviously your choice should be supervised machine learning algorithm. In supervised machine learning algorithm, whether how do you decide whether I should go with classification or regression based on the type of this output value or output column. So here are the discrete classes. So in discrete classes, so yes, have to go with classification algorithm. So here I will give you one more data set where I'm just trying to predict wind speed. So based on temperature, pressure, relative humidity, and wind direction. These are the input variables. Based on the input values or based on these input variables, I'm just trying to predict the wind speed. So, and this is, see, if you observe the wind speed column, so these are not the discrete values, these are the continuous values, right? So as these are continuous values, you have to go with, or you have to use regression algorithm. I hope you got the difference between regression and classification algorithm. Here, so I've given a scenario where I'm just giving some data to my model. Let's assume I don't know what type of machine data it is. So now I just give a new data. So based on the data, it has to identify this as orange. Okay. What type of machine learning algorithm will apply here? What type of machine learning algorithm will apply here? Anybody? What type of machine learning algorithm will apply here? Supervised, yeah, obviously supervised because data is labeled, right? So in supervised, so you have two categories, classification and regression. So how do you decide whether it is a classification or regression? If you are not allowed to mute yourself, you can use chat classification, yeah, obviously. Because see, I have given with some data and also labels. The labels are not continuous with this field, some classes, some class labels. Right? So then obviously your choice must be classification and here. So I have a data where I have an x variable and y variable. So as some x variable changes, y variable also changes. Right? So here what kind of algorithm will apply? Obviously the other the left algorithm, which is regression. Right. Thank you. Okay. So these are some of the examples of supervised machine learning algorithms. We have linear regression, logistic regression, nearest neighbor classifier, decision tree classifier, random forest classifier, support vector classifier, classifier, neighbors. And these two belongs to regression algorithms. Remaining belongs to classification algorithm. These are all the classification last, first two are regression algorithms, remaining are classification algorithms. These are the type of supervised machine learning algorithms. I hope everybody must come across, must have heard about these algorithms. Linear regression, logistic regression, nearest neighbor, K nearest neighbor, popularly known as KNN, decision tree, random forest, SVM, support vector machine, neighbors. Next, unsupervised machine learning algorithm. So what do you mean by unsupervised machine learning algorithm? As I told, whenever I given with the data, if the data is labeled, then you have to go with supervised. If the data is not labeled, see here, see I just given with the data, and I have given it some maybe some the vegetables. Okay, maybe the potato, sweet potato, or I don't know the other fruit. If somebody knows the name of the fruit, you can you can give a name for that. Okay, I just given with the data, but which has not been labeled. I'm not given with a label, right? In that case, I can't go with supervised machine learning algorithm. So obvious choice must be unsupervised machine learning algorithms. So by using unsupervised machine learning algorithms, can you give a label for this? Can you say these are all potatoes or these are all sweet potatoes or this is some other fruits or maybe some other vegetables? No, you can't give a label for the classes. Rather, you can categorize them into different groups based on the similar or common features. So you can observe it. See, so this data is given which has not been labeled. Obvious choice must be unsupervised machine learning algorithm. By using unsupervised machine learning algorithm, so what we can expect? See, they can be grouped into different clusters, different groups. One group, second group, and other group. This is what we can do in unsupervised machine learning algorithms. So then, as I told, so in supervised machine learning algorithms, mainly we have classification regression algorithms, right? Two categories. In unsupervised, do we have any categories? Yes. So what are those? So we have clustering and association analysis algorithms. Clustering. So what do you mean by clustering? These are just by just looking into by reading the name of temple, you can get to know about it. So clustering means by whenever I given with unsupervised data, using the unsupervised machine learning algorithm, you can make them into different clusters, different groups. That is called as clustering algorithm. Broadly, this technique is applied to a group of data based on different patterns. Based on the common features or common patterns, you can categorize them into different clusters. That is called a technique. Association analysis. And this technique is a rule-based machine learning technique which finds out some very useful relationship between the patterns of larger data set. Association rule analysis. When do we use this algorithm? Whenever we are for example, let's say I just wanted to know how maybe the senior citizen will purchase the item early in the morning. When they go for walking, like whenever they are coming back from walking, maybe they tend to purchase the milk, right? So whenever they are purchasing the milk, along with the milk, they also tend to purchase maybe some sugar, maybe some dress, and maybe newspaper, right? So whenever they purchase the milk, they tend to purchase a newspaper, right? Being a senior citizen, right? There is association between a milk and a paper, or maybe a milk and bread, or maybe a milk and sugar, or maybe milk and coffee powder or tea powder. So when we identify, if we can able to identify these roots or these associations between the items, definitely we can improve uh, the business strategies, right? In such a cases, to improve the business, to identify the associations between the products. For example, let's say I'll try to give the most best example. Whenever you visit any shopping malls, maybe maybe in Bangalore or Mysore, whenever you just enter to the entrance of any shopping mall, maybe towards right or towards left, you'll see 99% of shopping malls will keep the ladies' items like nail polish, or maybe the lipsticks, or maybe some cosmetics, or maybe some powders, or something like that, right? So and along you can also observe one more thing. So next to nail polish, they tend to keep nail polish figures, right? So there is an association between nail polish and nail polish remover. Whenever a girl or whenever a woman purchases a nail polish, they tend to purchase nail polish remover also. There is an association between these two, right? And also next to maybe nail polish remover, they may keep some other cosmetics, maybe some some perfumes, or maybe some other items, right? So they just try to keep the items together where whenever a woman or maybe a man, whomever it may, whenever they purchase one item, they tend to purchase another item. So these kinds of the recommendation would be you can observe in your maybe online carts, maybe in Amazon, or maybe the Flipkart, or maybe some other online shopping, whenever you're doing online shopping, and also you'll get some suggestion. Say, whenever you purchase some dress, so the people who purchase this dress also purchase this. Because most of the people when they purchase the other items, will get some the same suggestions. Where there is an association between two items, definitely it will improve the business the profit. Right? In that case, we use association to analysis or association interactions. These are the two categories we have with unsupervised machine learning algorithms, which are clustering and association to analysis. Some examples of unsupervised machine learning algorithms are k-means clustering, hierarchical clustering, DB-scan clustering, and BIRCH clustering. Semi-supervised machine learning algorithms. As the name implies, so this it lies between the supervised and unsupervised machine learning. For example, let's go back to this example. Here, let's say I have given labels with only few or let's assume I have some 100 vegetables or 100 items. Out of 100, let's say I will be labels for some 5 items or for 10 items. So whenever I give it labels for 10 items, I can't even go with supervised machine learning because not to go with supervised machine learning, we should need a label for each and every data, each and every observation, whatever we have. But whenever I given with some less number of labels, then what is your first choice? So the first choice should be apply the unsupervised machine learning algorithms and make them into different clusters, and based on the given few number of labels, try to give a label for the entire clusters. In that case, we can use semi-supervised machine learning algorithms. And setting semi-supervised, obviously, always you have to apply unsupervised machine learning algorithm first. On the output or on the outside output of unsupervised machine learning algorithm, you can apply supervised machine learning algorithm to give a label for the clusters. Next, reinforcement learning. So this is learning from mistakes or learning from feedbacks. So for example, the video games are industrial simulation. One best example I just wanted to give on this reinforcement learning is, so let's say you take a cab maybe in Bangalore, maybe from Majestic to maybe Vijayanagar. Okay, when you get down from the cab, you give some ratings to your driver, right? Driver will have to get a good maybe good salary or good points. He has to earn a good ratings. So how can he improve himself? So based on the rating, based on the ratings given given by him, you won't ask anything, and you won't say anything to your driver. You won't say like you just maybe let's say out of 5, you give just 3 ratings, and you won't say anything. You're a bad driver or rash driver, or the driver was not meant well, maybe just drive through the maybe traffic area. Don't give any kind of feedback, direct feedback. Okay, the feedback is in terms of indirect feedback, something like rating. Whenever I give a less number of ratings, maybe 2 ratings or 3 ratings, driver just needs to reanalyze things. Where was the drive the went wrong? Maybe slow, or maybe fast, or too fast, or maybe the traffic was very high. Where exactly I went wrong? So based on ratings given by you, just try to improve himself and just try to improve his rating maybe in the next steps. And that is the example of reinforcement learning. Yeah. Okay. And these are some of the basics of machine learning algorithms. So the only thing is, first we have to decide what type of algorithm we should apply. So whenever you are given with the data, if that data is labeled supervised machine learning, if the data is not labeled unsupervised machine learning. Again, in labeled, the output, if the labels are discrete, classification machine learning. If the labels are continuous, regression machine learning algorithms. In unsupervised, so you have to decide. Now unsupervised data, you have to decide whether what type of problem I am trying to solve. If I am just trying to make them into different groups, then you have to go with clustering machine learning, clustering algorithms. You just wanted to know the items are the patterns. I want to identify the patterns associated with some items, or maybe some association between the items. Then you have to go with association, meaning association analysis. Along with this, we also have a new category. This is that is called as dimensionality reduction. Again, dimensionality reduction is reducing the size of the data from huge dimension to a small dimension. That is also one of the category of machine learning algorithms. And some of the real-time applications of machine learning in networking, as this the theme of the FDP is network. I just added some applications where you can apply the machine learning algorithms in a field of network. So these are some of the applications of machine learning algorithms in networking, such as intelligent network traffic management, inbound network telemetry, resource allocation and congestion control, traffic classification, network security, cyber attack, identification and prevention, and phishing prevention. These are some of the applications or possible domains or possible fields where you can apply the machine learning algorithms in the field of networks. Let me let us discuss a bit more about the classification algorithms. Classification. So I will know that the classification implies classifying the data, classifying something into different classes. It's a supervised machine learning that is used to identify the category of a new observation on the basis of training data. Okay, so training. So here I added one more terminology, which is training. So before proceed further, let me give one more the important phase of machine learning, where whenever you are given the data, first you identify what type of algorithm you can apply. Whether artificial supervised machine learning algorithms or unsupervised. To be supervised, there is classification regression. To be unsupervised, there is a clustering or association or dimension theory. Okay, fine. So once you've done, decide with the type of algorithm. So what is the next phase in machine learning? So the next phase, you have to train your model. So what do you mean by training your model? For example, let's say. So let me give you in a simple term, simple term. For example, So let's say maybe at ISE, Indian Institute of Science, is conducting a competition on machine learning for engineering students. Okay, I have to prepare my students to participate in the competition. Right? So, as my students don't know anything about the machine learning. So what I do as a course faculty, I have to train our students, right? Before asking them to participate in the competition, I have to train our students. How do I train my students? As they don't know anything about the machine learning, what I do, I just prepare some important questions or some important topics. Okay, let's say I just prepare some 100 topics on machine learning, some important topics on machine learning, some important 100 topics on machine learning. I just prepare, let's assume I just prepare some 100 questions, MCQs, multiple answer questions. Okay, just prepare, as the competition is mainly on MCQs, I just prepare 100 questions on machine learning. I just give all 100 questions. I won't give all 100 questions to my students. Rather, I just use only 80 questions out of prepare. As I told, I just prepare 100 questions on machine learning. Out of 100, I just give 80 questions to my students and ask them to prepare. Okay, so they'll go back home and they'll prepare and come back maybe the next day. Okay, so in the next day, I have to test them before I select maybe the rule of the competition is I can select only the 5 students to get to be a part of that event, to be a part of the competition. How do I select 5 out of maybe from 100 students, or maybe from 50 students, or maybe from 80 students? So I've given 80 questions to my students the other day. So I just ask them to get prepared well on the questions. Next day, I have to test them. How do I test? I won't test them on the similar questions. I won't test them on the similar questions whatever I given yesterday. Rather, so I'm left with 20 questions, right? As I told, I prepared 100 questions. Out of 100, I just give only 80 questions to my students to get prepared. I just hold the remaining 20 questions with me. To test, I have to select best 5 students and use a 20 questions to test my students. So where? So with the 20, one more thing. So as I told, so out of 100, I've given only 80 questions. Those 80 questions also has got some questions and answers, both. Whenever I give the questions and question and answer, this is supervised machine learning algorithm, kind of thing, right? Supervised algorithm, so supervised learning. One second.
Balaji sir, sir, you are muted.
Oh, sorry, sir. One second.
Okay.
Madam, I have a talk and on 15 minutes. Yeah, sorry. Yeah. So to learn machine learning concepts, I've given 80 questions and an answer to my students and asked them to prepare. Right? To test my students. So I told I've just left with 20 more questions and answer. To test my students, I won't give both question and answer for that. I give only the questions and ask them to answer for the remaining 20 questions. So once they answer the question, I just compare the answers given by my students to whatever the answer I already prepared. So by just comparing the answers, I can decide, or I can select the best 5 students to participate, top 5 students to participate in the competition of E. Right? In the same way, the machine learning also. So whenever we are given with the data, I just showed you earlier. So the regression task or classification task, I gave some input and output data, right? The entire data is split into 2 parts. One is training data and testing data. So using the training data, we train our model, and to test the performance of our model, to check the accuracy of our model, we use a test data to check the accuracy of performance of the model. To test our model, we don't use training data. To train our model, we don't use testing data. Okay, don't get confused. So with the available entire data, we just split them into training data and testing data. What is the probability? What is the proportion of taking the training and testing? Obviously, the training data should be having higher proportion, higher probability compared to the testing data. So if you have 100 data, maybe 80% training, 20% testing, or maybe 70% training, 25% testing, or 70% training, 30% testing. Obviously, always the larger portion should go to training data, and lesser portion should go to test data. Right? So like this, we will split the data into training and testing data. Using training data, we train our model. Once we train a model, before I put it into real-time application, before any applications or any to solve any problem, I have to check the performance of a model. How do you check the performance of a model? By using a test data. So if in test data, if they are performing well, definitely you can choose that model with a good accuracy to performing real-time application. Right? That is, this is how the machine learning algorithms and machine learning training will work. Right? Yeah. In classification, let's go to as I told, binary classifier, and multi-class classifier. So we have 2-class binary classifier, and we have more than 1 class multi-class classifier. Okay, let's directly go to some algorithms. Yeah, as I told, so we have I told some 4-5 machine learning algorithms which belong to the category of classification, right? Such as decision tree, k-nearest neighbor, random forest, support vector machine, naive Bayes, so on. Right? Let us study about one such simple algorithm. The simplest algorithms of classification machine learning algorithm is the decision tree algorithm. Okay. It's a supervised machine algorithm. It is preferred to solve a classification problem. It looks like a tree-structured classifier. That's why it is named as classification algorithm. Okay. So, and this is same as what we studied in maybe algorithms, maybe the root node, leaf node, or subtree, or branches. Okay. So we have a decision node as a root node. Next, we have a subtree to the left and right part of the decision node. In the subtree, so we have a decision node. All the nodes are considered as a decision node except the last node, where the last node is considered as leaf node, which will give you the labels or output classes. Yeah. Why do we need to use decision tree? So what is the use of decision tree? And decision tree is usually mimic the human thinking ability while making a decision. So it is very easy to understand. That's why, so as I told, this is one of the simplest classification machine learning. For example, let's say, how do you decide? Maybe in the early in the morning, you have to decide what kind of breakfast you prepare. Okay, how do you decide that? You just search for the ingredients or items what you want. If you have maybe some vegetables, maybe you just decide, yeah, I have some maybe some carrots or maybe some potato or maybe some onion or some other. I can prepare the vegetable part. Okay, right? Yeah. So if I don't have a vegetables, then if I have maybe some leafy vegetables, right? Then I can go with some other dish. If I don't have vegetables, maybe If I don't have any vegetables, I maybe need to look at this. Maybe I can prepare some upma, or maybe some other the dishes. How do you decide that? Based on some ingredients available in the home, right? So in the same way, so in decision tree, we work with the same procedure. So here, maybe this example is maybe with respect to the COVID-19 situation. Yeah. So whether how do you decide this person will survive or not based on some conditions, based on the situation. So if she is a woman, she is a woman, yes. And if age is, if it is less than 30 or greater than 30. If the age is less than 30, probably going to survive. If it is greater than 30, probably if maybe if she is not a human, so whether exactly this is the COVID data, and this is belongs to the Titanic, the ship, the data. So the class whether is belongs to first class or other class. This is just a simple rules based on maybe some decision at each and every phase will decide the classes. In decision tree, we have three algorithms: ID3, C4, C4.5, and card classification declaration tree. So let us add the decision tree. Random forest. Okay. As I told, so in decision tree, we use only one tree structure. It will decide based on some conditions or some available features. So always a single tree is not better, right? A single decision methodology is not better. Right? So if we combine the multiple decisions together, that is a combination of the trees, is the forest. So that algorithm is called as random forest. Random forest is a combination of one or more decision trees. That is called as random forest algorithm. See here, I have a bowl of the fruits. I have to decide. I have to give the label for these fruits. So I just this is a first tree. Where in the first tree, I'll just use a condition as is a diameter is greater than or equal to 3. If the fruit diameter is greater than or equal to 3, this false, then one other the one fruit. If the diameter is greater than or equal to 3, it is true, then put it into another category. See, so whenever I decide, whenever I identify the condition or decision, whenever the diameter is greater than or equal to 3, if it is false, then obviously I got only one set of fruits into one category and two or more set of fruits into other category. So here I left with leaf nodes. And these are one labels, right? Here I have two more fruits, right? Is the color orange? Yes or no? If it is orange, then obviously they are one fruit, maybe the orange. If they are not orange, then apple. So this is one tree. The one tree says identify based on diameter, based on the color, it will identify into these categories. Next, this is the tree 2. When we use in tree 2, is first I use a decision saying is a color red. So this is I'm using a different decisions. If the color is red, if it is true, then I will put two fruits here. If it is false, then one category. Next, see I left with one category, the leaf nodes, one place. See here I have two more classes, two or more number of classes. Right? Again I have to apply one more decision. What is the decision I can apply? It is a shape circle. If it is circle, two, then one category. If it is not a circle, then other category. This is second tree output. Next, based on the third tree, this is the other. So finally, I just combine all the three outputs. based on the majority of voting, I just decide the final. Based on the majority of voting. So when I use three decision tree, based on at least two or more voting, just decide the class of corresponding vote. This is what the decision tree will do. Maybe whenever given this is unlabeled data. I don't know the label for this. So we are unable to categorize the name of this field. Right? So if it is diameter is equal to 3, color is orange, the grow in summer, yes, shape is circle. And second tree says diameter is 3, the color is orange, the grow in summer, yes, shape is circle. This is the third tree, diameter is 3, color is orange, grow in summer, yes, shape is circle. And the first three decide details may be the orange. The second three decide details maybe some cherries. Third three decide details orange. So out of 3 trees, we have 2 trees outputting it as orange, 1 tree outputting it as cherries. So the maximum voting is orange, so we consider it as orange. So this is what, the orange, cherry, and orange. So maximum voting belongs to orange. So I'll classify this as orange. K nearest neighbor algorithm. So this is another widely used, easiest, simplest machine learning algorithm. So based on common similar features, k number of features, k nearest neighbors. So based on k number of features, so we'll decide the class of the data. So see, I given with these classes, I have a category A and category B. I will give it a new data point here, which is labeled as blue. Right? I have to decide the category of this point, whether it belongs to category A or category B. Okay, for example, let's say I have a two students category here. So maybe students which are having which students are brilliant, students are weak. Okay, brilliant students and weak students, two categories. Given with the new student, one more new students, and newly joined students, I have to put them. I have to join out of the new student into either a brilliant category or weak category. How do you decide that? So I have to compare the features of new students with the brilliant student category features and also weak student category features. So with the maximum number of features mapping to either category A or category B, I can classify them into corresponding category. So this is how the k nearest neighbor classification algorithm will work. Okay, how does the k neighbor? So this is some algorithm. Set the number of k for the neighbors and calculate the Euclidean distance to k number of neighbors and take the k nearest neighbors as per the calculated Euclidean distance. Among these k neighbors, count the number of data points in each category and assign a new data points to that category for which the number of neighbors is maximum. So finally, our knowledge. Don't get confused. So let me give you a simple answer. So I have two category here, category A and category B. I will give it a new data point. I don't know the category of this. Okay. So this is obviously the classification problem. I have two classes here, binary class classification. Category A and category B. I have given it one more class. This is a new data point. I have to identify the category of this. Okay. Maybe I have two data points. Maybe these are oranges and these are maybe some the lemons, orange and maybe the musambi. Okay, I have given with one more data, maybe the lemon. So I have to identify whether this lemon belongs to the orange category or maybe the musambi category. How do you do that? How do I identify that? I have only two categories, either orange or maybe the musambi. So whenever I give it that, maybe some lemon. To which category I classify into? So whenever you compare the features of this newly given data with k number of neighbors, as I told, first you have to identify the value of k. To which number of neighbors you need to compare with, whether with 3, 4, 5, 6, 7, 8, or 10, 100, how many features you have to compare with. Maybe what are the features you can consider to compare the lemon with orange or lemon with musambi? Maybe the size, maybe the texture, maybe the color, maybe the shape. Right? This is some 3 or 4 features. Right? So if the lemon is maybe ripened, or maybe if it is orange or yellow color. So definitely you can put it into the orange color. If it is if it is in greenish lemon, definitely you can put it into in Muslim, right? So based on the color, based on the shape, all the three I guess similar shape. Based on the size, definitely you can put, maybe if you have lemon with a bigger size, definitely you can consider. Okay. Now let us consider. So this is lemon with the color the orange, the yellow color. Okay. So now when I compare the color, so obviously the color matches to this what the category orange category. When I compare the shape, some shape I have a similar features with Mosumbi also and oranges also. Okay, I got two similar comparison. Next, when we compare to shape, again the shape also same. So I compared the three features: shape, color, and shape, color, and maybe size. Okay, out of three features, out of three features, and I'm getting the three similar features with this category, orange category, two similar features with the Muslim category. So obviously we get a maximum rating or maximum number of features mapping to the category. So I identify this into category of oranges. This way the k-means method can be worked. Okay, as I told, I have to decide k values or k features to compare with. So what is the maximum number of, or what is the optimal number of k to compare with? Whether it is a 3 features, 4, 5, 6, 10, 11, 12. How do we decide the optimal value of k? So to decide the optimal value of k, we use a special algorithm called as elbow method. So in elbow method, let's say, let's make it so simple. Let's say this is with value of k, maybe this is considered the loss of a data. Okay, loss of your data, not the performance of your data, loss of your data, error of your data. Okay, and the value of k is 1, maybe the error is 2. The value of k is 2, the error is greatly reduced to maybe 40%. The value of k is 3, it has been reduced to maybe from 10%. And the value of k is 4, maybe from 11%, it is saturated. Conversion, right? So when you plot k, the elbow method to your data with k near table, you can observe such the elbow method graph in your program. So how do you choose the optimal value of k here? The point where your the algorithm started converging. Okay, so this is the point where your algorithm started converging. So that's why you can use the value of optimal value as k. So this is what the k algorithm will work. Let's know about regression. Some basic introduction to regression. Yeah. So in regression, these are the main different categories of regression that we have. Linear regression, logistic regression, polynomial regression, stepwise regression, root regression, exo regression, elastic regression. Some of these most widely used regressions are linear regression, logistic regression, and polynomial regression. Okay, and most widely used are linear regression. In linear regression, so when you go with a regression problem or regression algorithm, whenever you given with a label data, which has been labeled, and the labels are continuous. Okay, continuous. So then you will go with linear regression. So in linear regression, again there are two algorithms. One is simple linear regression, multiple linear regression. So we decide that based on number of variables, number of outcome variables available. If you have only one output variable, then it is simple linear regression. If you have two or more variables or outcome variables, it is multiple linear regression. This is the plot which shows the regression algorithm. So this is a simple regression line. What we are studying line of linear equation, y is equal to mx plus c. So y is equal to b naught plus b1 into x, where b naught is intercept. Intercept is, this is a regression line which cuts the y-axis. The point where the regression line cuts the y-axis is called as intercept. That is b1. B1 is slope. Slope of a line is the rate of change of y respect to rate of change of x. The unit change in x, whenever you change the unit of x, what is the corresponding change in y? That is called as slope. Okay, for a simple linear equation, in multiple linear equation, we have multiple lines and multiple slope. C is equal to beta naught, simple intercept, but b1 into x1, b2 into x2, so on, b1 into x. We have a multiple equation. What are some of the possible applications of linear equation? For example, predict the height from an age. Whenever the age of a person is given on x-axis, what is the height of a person? So, what is the height of the person with the age? Obviously, it is the height will be lesser, right? As the age grows, height will also grow. Maybe it saturates at some point, but so they are they're related, right? As the x increases, the age increases, the height also increases. Predict the house price from the house area. House area, the prediction of the house price. So for maybe some 200 square feet house, what is the price of a house? 300 square feet of a house, what is the price of a house? These are continuous values, right? Both x and y are continuous values. Predict the distance from the wall from the sensors. So these are some of the other applications you can use. Predicting the distance from the wall from the sensors. So if the sensor is at this much distance, what is the distance from the wall? Something. Yeah, you can observe, if you observe this graph, so this is a regression equation, these are the points, data points. So these are the data points plotted on x-axis and y-axis, where x-axis implies the times in terms of weeks, and y-axis implies accumulated savings in terms of dollar. So at week 1, the saving is maybe around $400. Week 2, the saving is maybe some $1,300. Week 3, the saving is maybe some $600. Week 4, $2,500. Week 5, $1,600. Week 6, $2,000. Week 7, something. Okay. When we fit a regression line to this, so see these points are actual values. These are all actual values. But when you put a regression line on this data set, every point will lie down or every point will come down exactly on this regression axis. So my actual savings when the first week is $400, but my model predicted it as exactly on the line, which is $600. My actual savings on the week 2 is $1,300, but my model predicted it as on the axis on the line, which is $1,000. My actual savings week 3 is $600. My model predicted it as $1,200, something. Okay? There will be an error whenever I implement the equation. Right? There is an error, right? So this is actual, that is predicted. Actual and predicted. Actual and predicted. Actual and predicted. So actual and predicted. Actual and predicted. There is an error, right? These errors are considered as the error term, epsilon. So that's why we have added epsilon here. You can see beta naught plus beta naught epsilon plus epsilon. This is random. This is the error, not your general. So yeah, prediction of nose price. So in x-axis I have a size in terms of square feet. In y-axis I have a housing price in terms of dollars, price in thousands of dollars. So I have let's assume I have the Excel sheet as CSV file given to me. When I plot a data on this, it just looks like this. The house with this size of maybe some 800 square feet, so which costs around some classrooms in $200. 1,000 square feet, maybe again $2,000. 1,500 square feet. These are some of the values plotted on x-axis. So as these are the continuous values, you can't go with the classification value. You have to use regression method. How do you plot a regression? You just need to draw a line such that it just passes through maximum lines, such that the error is reduced. Okay, regression. So as in regression line, definitely we have the errors. I have to compute the errors. Always that error should be minimum. Let's see if I have line something like this. This second regression line, this is third regression line. So comparatively, this is a regression line number 1, this is regression line 2, this is regression line 3. So comparatively, the regression line 2 is having a lesser error compared to regression line 1 and regression line 2. Right? So still I can optimize this, but this is the most optimal regression lines compared to line 1 and line 2. So always I try to fit my regression equation and regression line to the data such that the error is reduced or error is minimized. But how do you fit the line? Not to fit the line, I have to compute the slope and intercept. Once you get a slope and intercept, you can identify, you can fit a line. How do you identify the slope and intercept using this formula? But so as we know that, so now to implement the machine learning or deep learning algorithms, so we have programming languages like Python or the R. So especially comparatively, the Python is more advantageous compared to R, because for in Python we have modules or we have packages that to implement each and every machine learning algorithm. No need to write separate code, no need to write any equation, or no need to write extra extra lines to do any machine learning operations. So inbuilt machine learning algorithms, so just need to call a function and pass on the data. Everything will be done automatically. The training, multi-string splitting, everything for everything we have functions are the packages. You need to call the packages and you can get the output. Now to compare the accuracy of any regression equation, these are some of the averaging methods we use. Some of the errors, some of the absolute error, some of the squared error, mean squared error, root mean squared error. So that is the difference between the predicted value or actual value. No different. Yeah, as I told, and we discussed about clustering, right? In clustering, we apply K-means clustering is an algorithm where based on the similar features, we categorize into different groups. Also discussed about association rule analysis, right? Based on the common patterns, we'll identify the association groups. This is about some basic introduction to machine learning algorithms where you can use which algorithm to select. I know 1 hour is not at all enough to discuss about machine learning, but with a given time, I'll just try to discuss some of the basics of machine learning and some applications, how to choose an algorithm, some basic features of algorithm. So, and I'd like to thank the coordinators of this FDP to given the opportunity to be a part of this event. And also I'd like to thank Arvind sir, especially to giving me an opportunity. And also I'd like to thank our HOD and our principal for giving me permission to be a part of this event. Yes, thank you, Nanda. Any questions we can discuss?
Participants may ask questions if you have any. can pose any questions if you have any with Dr. Balaji Prabhu sir. So I think that they don't have any. Thank you very much, sir, for sharing your knowledge through this virtual FDP. I hope the participants have gained information from this session. Thank you very much, sir, for being associated with us.
Thank you, ma'am.
We will wind up today's session here. The feedback form, it has been posted in the chat box. Please submit the form within the time period. Tomorrow's session is going to be begin at morning 10:30. Thank you.